This is the format of the presentation. We have 45 minutes. We're going to give short introductions about what they are, what they do, and how it works. And then we'll take about 20 minutes for questions. I have some questions, but actually feel free to, even during that one, to raise your hand. At the end, I would open it up all to your questions. So with no further ado, we might as well get started. Why don't you go ahead? Yeah.
Oh, all right. Okay, so my name is John Amein. I'm with IDR&D. You might notice in your program that Alexei Kitrov was going to be here. Unfortunately, he couldn't be here, but hopefully I'll be a good substitute. I spent a number of years in telecom, 35 years or so in telecom voice. I've been to speech tech, I don't know how many years, so this is kind of fun. And I see a lot of familiar faces out there, actually, so that's also fun. IDR&D is a company with one of the sexiest names that you can think of. You know, IDR&D, isn't that great? But in truth, it is at least an efficient name. In 4 letters, we tell you pretty much what we do: identity, research, and development. So the focus of what we do is biometrics, because we believe biometrics is the best and maybe the only way to create a friend-like experience for authentication. And what I mean by that is, well, when you greet a friend, you don't ask for a PIN code. You don't ask to see a driver's license, right? You know your friend by how they look, how they speak, and how they behave. So those are the basic things that you would know as a friend and recognize someone immediately. And biometrics can do the same thing. So in an application, you have biometrics for voice to know how someone speaks, for face to recognize their face, of course, and typing. So that's behavior. Typically in an application, you're going to be entering text or typing. So those 3 modalities, we build all 3 of those modalities, biometric technology, and more than just the speech, although voice and speech are a very, very important part of that. And combining those is really our vision of what we think is the way forward. You know, conversational interfaces, being able to give a friend-like experience for authentication so that you don't have this PIN code, forgetting passwords, and all those other sort of problems with authentication.
Hi, my name is Roy Bentley. I'm with LumenVox, but have been in the voice technology world for about 15 years. Been working with biometrics for about 5 of that, mostly around speech, though at LumenVox our approach is we're kind of similar with the multimodal approach where we're trying to work with both voice and facial recognition. For kind of the same reasons. You stole a lot of thunder from everyone else, I think.
Glad I went first.
Because you went first. But conceptually very similar, you know, ease of authentication, reducing transactional friction, those sort of things, and trying to reduce, you know, the opportunities that exist for fraudsters to get access to, you know, legitimate information.
Hi, my name is Roanne Levitt. I'm Director of Product Management at Nuance Communications. So for those of you who don't know Nuance, we have several divisions. We're a public company, large public company. We have healthcare and we have enterprise. Within enterprise, we do just about everything voice that you can think of. My responsibility is the biometrics and security product line. So what we're seeking to solve is to make the customer experience completely seamless, frictionless, quick, and to detect and prevent fraud using biometric modalities, by using non-biometric prints, by using all kinds of intelligent detectors or risk engines. So there are many, many layers to achieving this.
I'm Ben Cunningham.
with Pindrop, does similar things as my panelist associates here. It's anti-fraud and authentication for the phone channel as well as IoT devices. So same idea, voice device behavior, looking for that verification to either authenticate or to identify fraud.
So, like it said in the list of questions in the blurb, one of the things we wanted to ask the panel was to give us some examples of best practices and also what not to do. We're actually now in a phase in this business where there are quite a few real deployments of this technology. You know, a couple of years ago, there weren't, but now it's been out there and, you know, people have had the success and also some challenges, and I was hoping that you guys might share some of those. And maybe we'll start at your end and work this way.
So I think one thing you're probably going to hear from all of us, best practices is, you know, people said multimodal, multi-factor, right? Using more than one thing to judge whether or not this person is who they claim to be, right? So if you just ask one question and, you know, if someone knows my pet is named Mr. Snuggles or whatever it was from this morning, I don't know how many of you caught that, but as a security guy, I cringed at that. I was like, so if I know your dog's name, does that mean I'm you? Like, best practices, obviously, you want to set policies and thresholds that actually allow you to operationalize the system. So one of the biggest things that we try to advise against, because spoofing is really big, right? Everyone's always like, do you stop spoofing? Do you stop spoofing? Here's something that I think we take a stance on that's different from the other folks is, yeah, there's a lot of people that do, and there's a lot of fraudsters that actually don't. You know, you can buy spoofing applications on the Apple Store right now, and you can get them for free, and it costs like a penny, and you can spoof your number and play tricks on your friends. So spoofing, if you stop spoofers, you'll stop a lot of low-level fraudsters. If you were alerted to every time someone spoofed into a call center, you couldn't manage the number of spoof calls, right? And just because they're spoofing doesn't mean they're a fraudster either. So if you're, you know, someone mentioned healthcare. If you're a doctor, you probably don't want your patients to know your phone number, so you're going to use you know, an intermediary like a Google number or something like that. So best practices are around, you know, setting policies that are going to allow you to, you know, achieve that balance between, you know, authentication rates and false positive rates. You know, you don't want to upset your customers too much. So I think it's really about the balance. It's really about those policies that you implement around authentication. Yeah, and I think the spoofing thing to me is the biggest pitfall that I think I've seen people fall into.
Yeah, so I agree with this. Sometimes we think that by detecting the incoming call and by recognizing that number or detecting it's spoofed, then we can take action. So it's not there's not a one-size-fits-all solution to this problem. It's a complex problem. There are many layers. There's, as my colleague said, there's some legitimate spoofing also. Sometimes you know, a doctor will provide an office phone number on their personal phone, and that's perfectly legitimate. So there are many factors to authenticating people effectively, and it's important to take in all of those factors and to have some kind of intelligent system that can analyze those factors. And the same goes with fraud. You know, you can't classify somebody as a fraudster, you know, based on simple pieces of individual data. It's an accumulation of lots of information. So it's hard to kind of wrap up best practices. I mean, there are so many best practices, but you know, in voice biometrics, you know, certainly you want to have good, solid enrollment profiles. You certainly want to have sufficient data and the right data and adaptive voice prints. But I can speak about best practices for 2 hours, so I'm going to stop right here and let the others speak.
All right, so I'll do one of each. So best and worst practices, or best practice and something to avoid. The majority of my background is implementation, hands-on, feet on the ground in front of the customer, kind of in that consultative role, teaching customers how to use the solution they've purchased, which kind of leads into the do side of this. Voice biometrics is not yet to the place that, like, say, an IVR is. It's not obvious to the people who are working on the system how it works necessarily, or the things that it needs. So it requires engagement from a lot of different skill sets within an organization to implement it successfully in a meaningful way. Sure, you can set it in front of your IVR and do a single shot, active authentication where someone says, for instance, my voice and my password's a really popular one. And is that the person on file or not? Good, move on with life. But if you want to integrate this deeper into a more complex solution, like the type of solutions we heard about at lunch, or the type of things people are imagining today, it really takes data from a lot of different places to really establish the identity of your caller. And you should consider all of the data points that you can pull in that exist within your organization's data to make sure that you're identifying this person as accurately as possible, within reason, obviously. But you have to make realistic policies, again, like Ben just said. And Roanne mentioned data, and I'm going to harp on data as well. The data you put into building a solution like this, the more data you put into it, the better it will be. The more accurate the data you get out of it will be. And I'll tell a blooper story here. I engaged with a customer who had purchased a biometric solution from actually my previous employer, who the call center staff had no say in it. The executives got excited at the technology. They really liked it. They thought it was cool. They spent the money. They went ahead and bought it. They went ahead and spec'd it without engaging their call center management whatsoever. And the spec they gave us was basically for an entirely different company, a company that didn't answer phone calls the same way they did. They had some idea in their heads of how this thing went together and how their callers interacted with them that was not meshed whatsoever with reality. And it seems kind of like a small oversight, right? Okay, yeah, course correct. It'd take a little bit of time to re-engineer the solution, that sort of thing. It kicked off this reiteration of over a year just to get the design corrected, because it then became a back and forth, right? And we had all these expectations set that were set with us, and basically everything we were told was wrong. And by the time, given their engineering time in the project and our engineering time in the project, there was probably a couple man years completely down the drain to build them out a solution that didn't work for them. And we eventually did correct course with them and spent some time with them to help them understand the technology, basically just a new engagement, right? Basically throw away everything they'd done, a fair amount of the money that was already spent on developing a solution on their side and on ours, and start over. And it seems like project management 101, right? Like, involve your stakeholders. But in something like this, where it's so integrated into your platform and into your customer experience, it's really super critical to have that.
So I think the three examples that you've heard so far tend to make an assumption about speech tech, maybe the show as well, is that it's about call center and IVR and telephony. And I just want to say that most of my deployments are actually not in telephony. So they're 90% not in telephony, they're mobile and web. So the experience that we have is going to be a little bit different. And what we've noticed that is debilitating to companies, what you don't want to do is forget the fact that you have, well, let me put it in a positive way. What you should do is design for cross-channel voice, because voice is becoming the king of the interface, as a user interface, which is great with all the natural language understanding. And what you need to do is keep that in mind. Some companies start with the call center, and that's where they first start experimenting with voice biometrics. And if you're going to do that, that's great. But you have to keep in mind that you should design for the fact that your customers are going to want to call in through their mobile, through the mobile app, for example, and use voice through the data channel, not through the standard telephony channel. And they're also going to be using conversational interfaces in the mobile devices and on the web. And because you have these conversational interfaces, you don't want to have to re-enroll. You don't want to have to go through put the customer through that hassle of re-enrollment. And why am I doing this again? And why are you making me do something different? So I think that's the main thing, is design for cross-channel from the get-go.
So this part is on performance, and I wanted to ask each of you to briefly characterize how your system works and how accurate it is and how long it takes to enroll and how long it takes to verify in normal usage. And why don't you start and go this way this time? Or
Okay.
tell you what, actually, Roanne, why don't you start and
Sure.
then move this
Yeah.
way?
All right, so for voice biometrics, as you may know, there are two types of voice biometrics. There's text-dependent and text-independent. Text-dependent being a self-service modality where the customer will enroll using a specific phrase. As Roy mentioned a few minutes ago, my voice is my password is a very common one that in our particular organization, we have very sophisticated background models trained on that, so it's quite accurate. So there's really not much to say about that model. We ask for 3 utterances. My voice is my password 3 times. And with that, we can create a very accurate voice print. And then with 1 utterance coming back for the verification, it's usually sufficient. So that system is quite mature. It's been around for a long time. The accuracy is well over 99%. So it works in most applications. For text independent, so the history for text independent, so this is free-form speech. This is conversational speech. What we like to recommend is on the very first call with your customer, after you've accumulated 45 seconds of net speech, so you remove all the silences and 45 seconds of their voice speaking, that produces for us a very, very accurate voice print for them. The technology has evolved significantly in the last few years with deep learning. Around 2015 was the first time we introduced deep neural networks. That was our first generation. Before that, we had I-vectors. Before that was joint factor analysis. But deep neural networks were in our 4th generation, and this last generation is very, very exciting because this last generation is called it's something called embeddings, and what that does is it gives us the ability to recognize an individual using unstructured speech, free-form speech, within less than a second of net speech. So what does that mean? That means that if you're developing an IVR application and you're using a voice IVR, as soon as the customer says a few things like, I'd like the balance on my account, that would be sufficient to verify them in using this new technology. So it's very, very exciting. In the call center, of course, within like a few, right now we do chunking in 3 seconds. So every 3 seconds we take the audio and we do a test. And usually in the first chunk, assuming that we have some audio, we can do a verification. Almost always by the second chunk where we can green light a customer. So very, very exciting, the advances in speech technologies.
So I'm going to kind of
reiterate something Roanne was just talking about. So there's two types of authentication. I think you're going to find that all of us, if all four of us have products that do this, all four of us have the same kind of paradigm around that, because there's one way or the other, right? Free, unconstrained speech, or repeating a specific phrase. So text dependent or text independent. Text dependent being also known as active, and text independent being known as passive. And I'd be really surprised if anyone told you they had a text dependent system with a less than 99% accuracy rate. Ours certainly is in the same camp, and single utterance, whatever the phrase is, right? Those things can be customized, or at least with our product you can. And it can be something as basic as adding, like, say, my voice is my password, adding, at your bank, your voice is your password, or, my voice is my password. Or something more complex like that, that maybe translates better into the local language. Like one of ours, we have a model that's literally in English, it is, my voice is very special and unique. But in whichever language, and I can't remember which, it's basically my voice is my password, just in the local language. For enrollment then, 3-ish utterances, depending on the language, the model, how accurate the model is, if we collected it from the data you already had on hand or whatever. But usually 3 utterances for the enrollment, and then a single utterance length for authentication. And then for passive or text independent, it's I think our system takes audio in 3 or 4 second chunks. It's similar, and can spit out an answer. Usually, depending on how many utterances we've trained with, if we've used one of your calls to enroll with, or 2 or 3 or whatever, we can usually get an authentication within the first chunk, that first 3 or 4 seconds of time. And we're accurate, we're at about 98% accuracy, about 97.5%, 98% accurate with that. And that accuracy changes depending on, I believe Nuance's system is similar, depending on how much audio was provided in the enrollment, right? So if you're enrolling someone with 15 seconds of net speech for passive, your accuracy is not going to be anywhere near 97% with anyone's engine that I know of. But if you're using multiple calls, 30 seconds out of each call or so, which is what we usually recommend, you can definitely see some really nice accuracy numbers.
Okay, so first of all, let me just clarify accuracy a little bit. They've quoted a single number, and that's a common thing that we do in our industry. It's the equal error rate, and then you subtract that from 1 to get the 99% type of thing. So equal error rate really consists of 2 types of errors. You have the false accept, allowing an imposter to get through, and then the false reject, which is you've stopped the valid person from getting through. You block someone, annoyed them basically, because now they can't log in or do whatever it is they're trying to do. So that trade-off, you have some flexibility over that. It's the operating point of the engine, but ultimately the equal error rate is how we can summarize the results in a single number. And our equal error rate for technology is in the range of this is testing on public databases. 0.3% for our text independent and 0.6% for our text dependent technology. We've, as Roanne mentioned, there's this whole new generation of technology. In fact, our company is fairly young. We've only been around 2.5 years, and we based the company on research and development that is really a brand new generation of convolutional neural networks, and we've just last year released what we call X-vector technology. So I think we're the first in the market with X-vector technology, and that's really given us a high degree of performance. In terms of the time to enroll, very similar. I think everybody's going to be somewhat similar in that we found statistically, if you get 3 enrollments, that tends to reduce the error rate in an actual transaction. which is different than the error rate that we're quoting as equal error rate. That rate is for a single attempt. But when you want to do a retry, your transactional error rate in your application is actually going to be better. So you can actually do better than what might be the single attempt because you're going to allow a retry. And therefore, you tune your system to be a little bit more of rejecting the false imposter. You don't let the imposter to get through, and maybe you have to allow a few more retries. But that improves your overall protection of the system and keeps your performance good. In terms of, let's see, I guess one other point, the reason that we need 45 seconds, I guess in the case of Nuance, or in our case 30 seconds is typically what we'll quote for text independent, is because you have to collect enough phonetic sounds from the person's voice in order to be able to identify that voice in the future. And if someone's pretty much saying the same kinds of things, you can even use 15 seconds if it's always going to be basically the same sort of phonetic sounds that come out of their mouth. But if you're trying to say, I can, no matter what that person says, I'm going to be able to authenticate you, then you're going to need 30 plus seconds of typical conversational speech. You know, this is sort of just rule of thumb. Statistically, typically at least 30 seconds, probably 45, for just being able to say anything whatsoever to be able to recognize you. So I think we're fairly consistent in that point.
So there's a lot of stats being thrown up here, so I'll try to boil this down into something other, maybe something a little more tangible, right? Because essentially the technology it's constrained by what's available. But think of, so as we determine what's the minimum amount of speech, we try to think of it realistically, right? So we've found that in testing, the minimum, and I don't think this will surprise anyone, is 3 syllables. And it's not a coincidence that that's how many syllables are in Alexa and Hey Google and who's the other? I don't know what Microsoft's wake word is, but it's essentially the same thing, right? It's designing for one breath utterances. So that's where you kind of aim to, right? But the reality is your device, the background noise, everything influences it, right? You could have someone do it 3 times perfectly and then they call from a convertible and a Bluetooth phone, and they're like, I don't know why it doesn't work. So I think we also have to account for, that's working under optimal conditions, and we could all debate on equal error rates all day. We see it differently. We see as, how do I authenticate or how do I find fraud in a life cycle of a phone call? We can do it without any voice. So again, going back to that multimodal or multi-factor, 80% of IVRs aren't voice enabled, right? So what do you do with that? You can't get 45 net seconds of speech out of someone not saying anything. So you have to look at other factors, right? So we can use metadata analysis, and actually we could authenticate at some level 70% of people that call in based on if you have their phone number on file, just because we can vet the caller ID essentially. We can say, hey, that caller ID, it's not spoofed, there's no risk. So yeah, if you just want to let them check their balance, things like that, that goes ahead. Other things like enrollment rates, it varies on how often your callers call back in, right? So retailers, how many people call Home Depot more than once in their lifetime? Probably not too many. So you have to think about, well, what does the enrollment process look like? And I'm going to go back to best practices for a second. If you just roll out voice biometrics and just say, okay, everyone enroll now, there's a couple things wrong with that. One, you could, without any risk validation of who's enrolling, you don't know who's enrolling the first time. So you could be enrolling a fraudster. Secondly, also, if you have to spend, 45 seconds or, have someone repeat the same phrase in an active situation, if your goal is to reduce average handle time, that's really going to blow the metrics out of the water, because now you have to take an additional 2 minutes to stop and explain what they're doing, how many times, what they have to repeat. So we don't really see that as optimal. So our solution really just it's passive like the other ones I've mentioned. We just stitch however much speech we get to together, and the more they talk, the more we have on file. But we're also looking at, device printing, metadata analysis, and all those combined. So even if they don't talk through the entire conversation, there's still elements there that we can say, yeah, this person is who they're claiming to be.
I'm actually going to skip over this one, and maybe we'll come back to it. But I wanted to ask, in particular spoofing, not necessarily anti-spoofing, but how do you fight somebody like detecting a recording of somebody or something like that, so that where they're making up and trying to spoof you? What techniques do you have to try to deal with this? And maybe you want to start?
Sure. So just to level it up, we call these deep fakes, right? We try to think what's the largest example. A deep fake is, like you may have seen on television, someone has a recording of Barack Obama and speaking, and it sounds just like him, but it's someone else actually creating those words, right? Synthetic speech, synthetic videos, which we believe present a really credible threat to, honestly, our way of life. And I know that sounds like really big, but imagine, someone posts an incendiary video by a leader to another country, which enrages them. And anyway, I think maybe we can all agree that they're dangerous. The way to detect it is, things like liveness detection, synthetic speech detection. Basically, you're looking for any anomaly. Our system, it's really interesting how our deep voice biometrics work. Instead of just, does this match the arithmetic of another call or probabilities, it actually, the way I think about it is the system actually tries to reverse engineer what the person's throat had to look like in order to produce that sound. So if it's a recording, it's going to really, really impact how that sounds, right? There's distortion in there. So, evolution took millions of years to develop our voice box. So someone doing deep fake, right, they're not thinking about that. They're only trying to fool your ears. They're not trying to fool something that knows your anatomy. So when we look at, deep fake things like that, and our technology will show, well, someone would have to have an 8-foot tall neck to make that sound. So it's really based on what's possible with the nerves and muscles in your larynx. But I think detecting that, it's a challenge. It goes greater than just authentication. With authentication, you're matching a one to a known other, right? It's a one-to-one. Where deepfakes, you just have to say, is this anybody else? Which is a really tough problem to solve. So you're going to have to look, pretty unscrupulously at things you can't hear rather than the things you can hear, just because it sounds the same, right? So those inaudible characteristics, our phone printing technology picks up on 1,800 some odd things that the human ear can't hear. So it's going to take a level of essentially machine learning and artificial intelligence to be able to discern out this really quickly from those types of bits and bytes of audio.
Yes, so the spoofing problem is a big problem. So it started with, patching together my voice is my password utterances by getting somebody to say all of those words individually and then putting them together and then using that to spoof a text-dependent system. Well, there are technologies available that can detect playbacks, and they can detect the acoustic signals essentially that are produced when you play something back through speakers. So anything that's played back through a speaker can be detected. So that's one aspect of it. The real challenge right now is all of the advances in technology for synthetic speech detection, right? So now you could, and it was mentioned this morning, Lyrebird is one example of a company who will allow you to go to their website and allow you to provide 30 utterances, 30 phrases, and then they will produce your synthetic voice. And then they could use that to try to spoof these systems. But the technology is getting better and better in synthetic speech production, and someday we'll be at the point where we'll have, you know, real-time voice conversion, where you can actually have a fraudster talk into a microphone or talk into their system and have the system in real time change their voice to your voice, so they can actually live answer the questions. So that's a real threat. I know at Nuance we have a fairly large research team that are continually looking into the synthetic speech production systems and detecting when the speech comes from these systems. They're detecting specific parameters, specific elements of what those systems are producing to be able to detect that those systems are actually producing that voice. But that's not enough, because it's always a race, right? They're going to one step ahead, we're one step behind, then we catch up, and then they move one step ahead. So we have to be very careful. We've actually requested that the companies who produce these synthetic speech systems put watermarks in their transmissions. And if they were to agree to do that, then the nefarious folks would not be able to use it to try to spoof these voice biometric systems, because we would be able to detect the watermarks. But unfortunately, they've refused. So other techniques are important. And one of the things that we've actually recently, a new innovation we've come up with, which will help a lot in this area, not just detecting synthetic speech, but it's a new biometric that we call conversation print. So it's a conversational biometric. So now you're not only detecting how somebody produces sound, but you're also detecting how they choose the words they use, the grammar, their sentence structure, their vocabulary. So and if you think about it, if you were to speak to somebody you know well, or to a family member, and things would come out of your mouth which are not characteristic of you, they would probably notice that. So now we've actually been able to package that into technology. So many layers. You add all of these things together, and again, it's a race.
That it absolutely is. So it's definitely a bit of an arms race here. I think we're helped if we're all considering ourselves kind of white hats up here, right? I think we're all helped by the fact that the technology's not there yet, as far as generating a synthetic voice that can fool a synthetic speech analysis algorithm. I don't know that that's there yet. In fact, most of us can hear a synthetic voice with our ears, and it's going to have to pass that point before it can pass muster against an algorithm. But it probably will get there one day, and a multi-layered approach is going to be the only way we can win that fight. Another thing we do that I haven't heard mentioned yet is we look for duplication utterances. So we look for, have we heard someone say that exact phrase that exact way? Because we all differ in how we speak. Even if we say, my voice is my password 3 times in a row, we didn't say it exactly the exact same intonation, exact same place in our breath as we did the time before. And so that's a thing that we do on top of having algorithms for liveness and synthetic speech detection that looks for those sort of anomalies.
Well, so spoofing is critical, because if someone's able to spoof you, then the biometric part of it is useless, right? So it's critical. And there are three kinds of spoofing that take place. One is the playback attack, where it's a recording of your voice. A second is a synthetic voice, which I'm glad all of the panelists here have talked about as being an upcoming and major threat. And then the third is software that converts your voice. So it's taking someone's voice and then it's trying to change it into something a little bit different. And there are various reasons why you'd want to use that sort of technique to disguise your voice, for example. So There's an organization called asvspoof.org. You can go to the website. It's a global consortium of speech experts who focus on testing spoofing in particular. So Google contributes to it. Some Chinese companies, a bunch of companies contribute to the corpus of data that's associated with this. And I'm really proud to say that the 2019 results of this global competition challenge are out, and IDR&D is number one in the world of detecting synthetic voice. So that just came, it hasn't, I don't think it's published on the website. If you want to, I can give you some preliminary stuff if you'd like to see it. But that organization, I think, does a pretty good job. In previous generations of the test, they've focused on the playback attack. And I'm pretty sure that all of us have that issue to deal with. We have anti-spoofing on the mobile, where we can detect the fact that someone it's a live person, because the vocal tract and the larynx discussion earlier, it's sort of a tubular shape, and it creates a different kind of sound as compared to a flat speaker that's projecting. And we do detect that, and we've done that very well in our technology. When you do that over the telephone channel, it gets cut off because of the high frequencies are cut off on the telephone channel. So playback detection of the telephone channel is a big challenge for recording playback. So it's not, there are different techniques that you have to do in terms of the user interface to truly combat the playback attack over telephone channel.
Okay. My last question was just in the legal realm. There are, the first off was the General Data Protection Regulation, GDPR in Europe, and then there's been some state law in the US. And I was wondering how this is impacting your business.
So obviously privacy is at the forefront of a lot of people's concerns. Anything considered a biometric can fall under some privacy laws. So there's a couple states, Washington, Illinois, a couple others, that have to get, in some cases, even written permission to actually use those things. So voice is delicate, although I never quite understood that, because this panel will correct me if I'm wrong, but a voice print is like the calculus of your voice. It's not your voice. It can't be reverse engineered to create your voice, so I never understood why that's a privacy issue. That's like my suit measurements are like, a privacy issue. I never understood that. It is a concern, and it's up to the interpretations of a lot of the legal entities that rule either a state like France, or excuse me, a country like France, or a state like Illinois. And it's up to the vendors that we work with for them to decide how they comply with the law. We built in tools for instance, that depending on the area code that dials in, it can turn the voice down. It has features where you can actually have the representatives actually turn it off. So if they're saying a credit card number, it actually doesn't ever get recorded. And we do things like ensure that any sort of recording data stays on the customer's premise. A lot of times this will suffice for most legal entities, along with a lot of written down documentation that, okay, this is something that we can pursue. But, I think, it's something that we have to deal with, but for good reason, right? Privacy is important regardless of my feelings on a voice print. But, yeah, I think checking with your legal teams and checking what, and it's industry dependent too. So if folks in healthcare have different regulations to look at than a bank, for instance. But again, it's does the solution have the right tools for the areas that concern me, right? If I'm a retailer, I don't want to record anyone saying a credit card number. If I have customers from Illinois and I can't record their voice whatsoever, I have to have an intelligent solution to deal with those problems.
Quick question, that kind of precludes you using the recorded, is it the same recording as I just heard? I have to have had the recording saved.
This is true.
Yeah.
But that's one layer out of several that are used for liveness detection, liveness verification.
Right, but your
But
approach-
you end up precluding some of those, or not even being able to use the incoming call to try to detect fraud or anything like that, because Illinois especially, Illinois' law on this is basically draconian. I mean, I've had one customer try to use customer data from their Illinois customers. Every other customer, every other of my customers have elected to just not address Illinois at all, and they did that either by area code or by address that they had on file for the customer. And I've seen both as the solution. I've seen a customer use area code, I've seen one use state, and I've seen several use both. If they have either, they're just not eligible. They won't be presented with the opportunity to enroll.
Does anybody else want to talk about legal stuff?
Sure. So I'm not a lawyer, and if I were a lawyer, I wouldn't be your lawyer. So whatever I say is just my opinion or my point of view. There are a number of things that, that we've done to take into account these privacy regulations. So GDPR was it's a European regulation, and it's based on they're all basically based on consent, primarily. But in the GDPR, there's the concept of a controller and the concept of a processor. And as long as you're, as a vendor, as a software vendor, as long as we're providing our technology to our customers on-prem, so they control the systems, we are not a controller, nor are we a processor. And therefore, it's really up to our customer to make sure the correct measures are in place. As soon as you provide a service on the cloud for GDPR, then you become either a processor or a controller or both. And that's where you have to be very careful. If you're going to be a processor, then you have to make sure that all of the regulations are taken into account. And the process we had to go through for that, or I had to go through, as a matter of fact, for that, is our legal counsel would go through what we call a PIA, a Privacy Impact Assessment, and ask a whole lot of questions about what kind of data are we collecting and what are we doing with the data, what's our intent, how long are we going to keep it, and then produce a whole assessment on risk and figure out the remediation for that risk. So it's a very, very lengthy process to make sure that, that we don't make any mistakes and we comply with the laws. In the U.S., it's a little bit different. So the three states that I know of that really have specific legislation on this are Illinois, Texas, and Washington. Illinois being the most restrictive. So, our legal counsel basically said we need to go with the most restrictive and make sure that we're complying with those laws. And there's a concept of biometric information and biometric identifiers. And again, I'm not a lawyer and I'm not an expert in the field, but there are a lot of hoops that we have to go through to make sure that we're compliant as a processor and or controller. But as an on-prem service provider, that's really outside the scope of what we need to take care of.
I'd like to just say that there are people freak out over the whole GDPR and everything, and they needed to because it was all brand new. The three basic rules, and there's a lot of details, as Roman was saying, that you got to go through, but the three basic rules are, number one, you absolutely need to get consent. If you don't get consent, you're really blowing it. So make sure you get consent, and that's one of the reasons those lawsuits happened in Illinois. It was like the vendors, Six Flags, they were just stupid. They were absolutely just stupid. So get consent, number one. Second is encrypt or protect the data just like you would secure any important data. And believe it or not, some people don't do that. So, you just absolutely got to make sure that you encrypt and protect the data. And the third thing is you have to be able to delete the user if they ask. If you can do those three things, you've probably solved the problem, and it shouldn't be really outside the realm of the company's ability to do so.
Do you have,
Go ahead.
in your integration process, a lot of tools to allow a person to say, I'm sorry, take mine off your thing, and they go through the process, and and a user interface, or have to go to a website, or what, how do you handle that? That could be a whole nother stack of UI if you're not careful.
Yeah, it's identity. You're storing someone's identity, and that's typically a database type of format. So the delete becomes basically a database type action. It's not that complicated if you design it.
Mechanics
in-
of deleting it is fine. It's mechanics of you getting the user to be able to do it and to know they can, and what's the process, and how do I make sure it's
Yeah.
the proper person deleting it?
Yeah, it becomes a
Yeah.
part of the customer service process, really.
Yes, so it's our customer, so the end consumer is not our customer. Our customer is the bank or the telco or whoever that is. So,
It isn't the individual?
No.
no, our customer is not the end consumer. So
I
the,
understand
the,
that, but they own, doesn't the end consumer own their voice print?
correct. So the consumer now asks our customer, maybe a large financial institution, that they would like their biometric data, all of their personal PII in essence, to be deleted. And they are obliged to do that within a certain time frame. And so they go into our system and they execute those operations to delete it from our system.
So we've actually run out of time. I'm sure that if you care to come up and ask some final questions when we're gone, but please have a hand for the panel.
Time flies when you're having fun.